Okay. So yesterday we went over the ones that were compound interest. And we used them because it had the word what in the question? Compound. So you use the compound interest formula, correct? Today, we have the same things as yesterday. We have final. We have initial. What was here instead of an R yesterday? A little I. What did it stand for? Interest rate. Still the same thing. And then N is number of years. Because it does not matter what the variables are. That's the point. The point is that what's on the left is always your final. What's on the right directly of the equal sign is your initial. What you add to it is your interest rate, and the exponent is your number of years. Okay? So the first one I have plus the interest rate. The second one I have minus the interest rate. What do you think is happening? One's going up, increasing, and one's going down, decreasing. So if it says that it's increasing and doesn't have the word compounded in it, we're going to use the top formula without the CPs, correct? So it sounds very similar, just to have compounding in it. So it's not every month the interest rate's not getting put back in your earning, right? That's the only difference. If it says decreasing or depreciating, then we're going to subtract our interest rate. Okay? So if I have 1 plus, sorry, it's just an aside, we're just paying attention. If I have in that bracket 1.05 to the n, am I increasing or decreasing? Increasing by how much? Nope. How much am I increasing by? How much interest?
1%. Some percent.
It's normally 1, and then we add our interest rate. So how much more is this? 0.05, right? So it's increasing by 5%. What if I have this? 0.95 to the n. It's decreasing by 5%. A whole bunch of people will tell me it's decreasing by 95%. It's not decreasing from 95%. What are we starting at? 1. So how much are we subtracting to get 0.95? 0.5, so it's 5%, 0.05. Okay? Matthew, do you have a problem? Really? All right, so let's look at the first question. In 2012, the university population of a country was 160,000 and was increasing at an annual rate of 4.5%. And it says increasing, that's the huge important part. And it doesn't say compounded in it, so we don't have to use the CP part, right? Determine the population in 2005. So from 2012 to 2005 to the nearest whole number. And that's 15. I know. I was just checking to see if you're paying attention. No, I'm wrong. It's fine. Okay, 2012 to 2015. So, goodness, that is a bright light. I'm going to go on this side. So, what did they give us? They gave us the initial. The initial was 160,000. They gave us N. Someone said that. What did they give us N? 3. What else did they give us? They give us the I or the R, whatever we want to label it. And what is it? 0.045. I would rather you go 4.5 divided by 100 every single time and feel like you're not smart, because that's why you don't do it, but I don't care. Please do it. Then you give me 0.45. Okay? It happens all the time. So go 4.5 divided by 100. That is a much smarter plan, please, every single time. Okay? And then write down that decimal, or else you might write down the wrong one, which happens all the time. So it's 0.045. So please take the percent and divide by 100, okay? Every single time. Please do that. You paid lots for the calculators. Get your use, all right? Okay, what did they not give us? The final, the A. So we have A equals 160,000, bracket. 1, now we have to decide, are we adding or are we subtracting? You're adding because it's increasing. by 0.045. And our n is 3. Now, I get people y1, y2ing. I get people trying to do crazy math. This is just literally math. Just type it in and get an answer. Okay? Your answer should be greater than what? 160,000 because it's increasing. So we're going to go 160,000 bracket 1 plus 0.045 to the 3. Now, our answer is 182,586.58. How many people is that? Yeah. Can we just randomly find half a person somewhere? We can't just randomly find half a human. So if it was time, we would round up, right? But it's, yes, we round down because you can't just randomly find half of a human floating somewhere. So it's going to be 182,586. No.
Why not 87?
I just explained why. Okay. 182.
It's 5. You have to round up.
You cannot get half a human anywhere. No half a human found. Okay, so we have to round down because you can't find a random half a human somewhere. Round down when it's a human. For example, I want to explain to you, this is an explanation as to why. So, say you're trying to figure out how many cows can fit into a trailer. Okay? They say that 6.7 cows can fit. So then you guys tell me 7 can fit. The cow's butt is hanging out of the trailer. It is not fitting. That is not 7 cows. We would have to round down to 6. So think about it as cows in trailers, people. Cows in trailers. Cows in trailers. So if we could only fit 182,586.58 humans into a trailer, this is really weird right now. We can't. We can only fit in 182,586 humans. Super creepy. Okay, 182,000. What was the answer? I can't remember. 586? Boom. No. All right, number 2. Try it out. So this one says the number of fish in the lake is decreasing. So I'm going to use what? 1 minus. By 5%, so my R is 0.05. If there was 2,500 fish present in June 2012, if you don't know if it's the initial or the final, you have to look. Is it the earlier year or the later year, right? For it to be how many, I know it says man, but you can adapt, would you expect to be present in June of 2017? So June 2012 is the initial, right? So it's the P, 2,500. And then what else did they give me? N is 5. And so I'm going to go A equals 2,500, not sure why I'm putting in bracket. 1 plus, 1 minus 0.05 to the 5. And what do we get? How many fish do we get? 1,934. Okay. Number 3. Last one. So a truck bought for 35,000 is the what? Initial or the final?
Initial.
Depreciates by 12%. Quiet, please. Depreciates by 12%, so 0.12. Depreciates means we're going to subtract. How many years, so they want the N, would it take for the value of the truck to reduce to 1/4 of the original price? So whenever it says of, that means multiply. So you can either do 35,000 times 1/4, or you could go 35,000 divided by 4. Either way, we get you the same amount. What is it? What's your 8?
875.
8,750?
No. Yeah.
I think it is.
Yeah, no.
I'm like, I'm pretty sure it is. Okay, so we're going to have, why is this final smaller? Does that even make sense? It's decreasing. So when it's depreciating or decreasing, our final should be smaller than our initial, right? If it's increasing, our initial should be smaller than our final. And then we have 1 minus 0.12 to the n. The first thing we do is divide by the 35,000. Quiet, please. So if we go 8,750 divided by 35,000, you're going to get a quarter. Why would we get a quarter? Because it's a quarter of it, right? Then we get 0.88 to the n. Stop. What do we do now? We can make it a log. So we have y, a, x. So we're going to get n equals log base 0.88 of a quarter. Now, if this wasn't a written response, I could have y1, y2 then, correct? And found it there. So log 0.88 of a quarter, math, 0.88. And I get 10.84454196. So how many years would it take for it to be less than a quarter?
11 years.
11. And it says to the nearest whole number.